All right, Bob, I think we can start our webinar on wallchart. Well, you can start the presentation. I can read the title.
Okay, no worries.
All right. Understanding wallchart, fundamental of EX. So now, let me see if I can take control of it for the beginning of it. Request more control. Request.
And it has been approved.
It's been approved. So now I'm in control for a few slides. Guys, before we begin our webinar, let me introduce you, Bob. I'm Paolo. You guys know me. Most of you might or might not know Bob. We run several webinars as we were discussing just a little bit ago. But anyhow, Bob is our guest and our speaker, and he has over 30 years of experience in the EX world, being a CompEX instructor and an instructor for the ICEX CompEC scheme. Start to getting that right. He's also an inspector and a member of the US UL STP committee. He runs a company that deals with IX and EX products, so he's very, very qualified to run this webinar for us. Before I let him talk, I need to take a few moments of your time to introduce GMI, our company, what we do, why we do it, and why we spend some time preparing these webinars. We are a safety company, GM International, or GMI. We design, engineer, and manufacture a complete range of IS and SIL certified devices, interfaces, for most automation packages, DCS, ESD, SCADA, PLC, and so on. We use them in all the industrial sector, primarily in oil and gas, petrochemical, but also in food and bev, pharmaceuticals. We have over 40 years of experience, and we are very proud to have our manufacturing in Italy, in our headquarters near Milan, Italy. On the other hand, we are a global player with presence in all the continents. Because we make safety our priority and we make safety product, we take special care in manufacturing those products. So we have a full state-of-the-art technology, engineering center, production center. We have full traceability of our product, all the incoming components to the outgoing components. You give us a serial number, we tell you the complete history of that product, including who tested it. And we do perform 100% testing on all of our products. And of course, we are ROCH and risk compliant. Now we have to be, there's a new law, Bob, it was just introduced. By January, we have to comply to some ECAS. I don't know, guys. I haven't been following. I'm a sales guy. Anyhow, we will make a declaration very soon. We try to be, 100% compliant. We have a lot of certifications, including SC3 certification by TUV, meaning that our processes are up to SIL 3 certified, because we make SIL products, so we need to have a complete process that is compliant, systematic capability. We design and manufacture those products, for a better world. Less risk, less accident means a better world for all of us. And these are the products we manufacture: IS barriers, safety relays, with and without line monitoring. We have isolators, also SIL certified. Power supply, some of them SIL 3 certified. We have multiplexers, temperature multiplexers, arc multiplexers. We also have a line of termination board compatible to all the system out there, and surge protection device, some indicators, and we run a service division that provides functional safety and EX training and services. Although 2020 we're seeing, besides this webinar and live, we are now going back, Bob, I don't know if I can mention it, but we are going back to have some training. I mean, we can mention it. I don't want to spoil it. How do we say it?
Well, no, we are planning on.
Yes, we are going to organize our first training class in October, November here in Italy, inshallah, if things don't get worse. Now we are about 10 offices around the world, and we have many distributors, about 200 people, and we used to run many courses. We will go back to it. We have thousands of installations. And these are our customers. So we have system vendors from ABB to Yokogawa, basically all of them. Many EPCs, we've done projects all over the world with them. We also supply to many OEMs on their gas turbines, skids, wellhead packages, motors, and so on. And we are in the AVL on many end users. I believe that's it. So I ran by a little bit. Now I let Bob talk. Before Bob, you start talking, let me again repeat that you guys, there's a way for us to talk to us is to use the question and answer box. So you can post questions throughout the webinar. We'll try to answer them throughout it or at the end. Let me give you up remote control so you are back in line. Okay, guys.
All right. Well, thank you, Paolo.
All yours. I'm here. If I disappear, I'm here. I'm just trying to read your questions.
Understand. No problems. Well, thank you very much for allowing me to join you, Paolo, again, as it's always a pleasure. This was a new topic, and this is the first time we've run this webinar, as Paolo mentioned. And I thought this would be kind of interesting. We've had a lot of EX questions in some of the other webinars. And of course, many people get wall charts, right? You've probably seen them. You may have them yourself. And they're very nice. Salespeople come in, they give them to you. You have them. You may put it on your wall. And they're tremendous assets. But a lot of times they get put on walls, and then people kind of forget about what's actually on there. So I figured this might be a nice opportunity to kind of really have a quick little fundamentals webinar on some of the EX requirements and some of the markings and all that good stuff. So hopefully this will be entertaining, answer some of your questions. And as Paolo said, we did get some really good questions that we'll put in at the end. And we do have some poll questions, so please pay attention. These are not simple poll questions. You won't be graded. Don't worry about it if you get the wrong answer, but we'll explain all that good stuff as we go along. So some of you may be familiar with this wall chart that GMI has published, and this is available to all of you. And so certainly if you'd like a copy, a nice glossy copy, we can get that to you. But we're going to spend some time kind of going through this wall chart, explaining what's on here, and hopefully answering some of your questions that you might have with regards to EX.
Yeah, and Bob, you know, as we did with the Yellow Book, when we did the webinar on the Yellow Book, we are going to give you guys a copy of this. We have 2 posters. We'll give you a free copy. You know, you just send us an email, or we probably send it to all the participants. Please go ahead.
Yes, yes, absolutely. So starting off with area classification. Before we actually start selecting products, we obviously need to know what is our area classification. How do we classify it? How do we designate it? And so the main standards that we follow in the international world are the 60079-10-1 standard that deals with gases and vapors, and then the 10-2 standard that deals with dust. So when we pick up those standards, that basically gives us all the information on how to classify a flammable gas atmosphere or a dust hazardous atmosphere. So when we see this on their area classifications, and we'll talk about this further, we then classify them based upon the zone concept. There are some other documents, however, that are not located on this wall chart, just to be aware of, because you could see this in specifications, and these are widely used documents as well for area classification. There's what is called the Energy Institute IP15 document. That is a well-respected, very extremely detailed methodology that many oil and gas companies do use for their area classification. In the United States, we also use what are called American Petroleum Institute recommended practices, which are located in 500 and 505. So this is how we would do area classifications in the United States. We could also be using what is called an NFPA document 497. So generalities, when we look at this wall chart right here, and I'll see if I can annotate. I'm going to try to do this here without screwing everything up. We basically, if you notice, we have a group 1 and we have group 2 hazards on the international side. So anytime we see a group 1 hazard, that applies to below ground industries, Group 2 hazards deal with surface industries. So a vast majority, I assume, of all of our attendees today are not dealing with Group 1 hazards. We're primarily in the oil and gas or pharmaceutical industries, or in the, obviously, the food processing with grain elevators, things like that. It's all going to be Group 2 type equipment. So let's clear that. We'll go to the next slide. Hold on. Oop. Got to close that out. Here we go. So, furthermore, we provide equipment category designation in the following. So now when we start getting into the equipment, we talk about M1 and M2. These are equipment mining groups. And again, this applies specifically for subsurface applications. This doesn't apply for normal oil and gas or pharmaceutical or process industry type applications. However, when we start getting into 1, 2, and 3, these now start telling us about surface equipment groups. So if we notice over here, we start seeing 1, 2, and 3 on the far right-hand side. Those are considered to be categories under the ATEX category. And then we also find those referenced as EPLs as well, which we'll talk about here in just a second. And then finally, we have a designation of gas or dust. So what we see over here, a G or D or both, these are gas hazards. So just using this example right here, looking at our wall chart, a zone 0 environment is an environment where it's continuously, it's considered to be a zone 0. We would consider that from a manufacturing standpoint, equipment category 1G, or under the IECEX, we would consider that to be a GA. So this is, if we had the same thing located for, say, for example, a dust hazard, we would have 1D and then have something with a DA, okay? So this hopefully shall explain just a little bit about the explosive atmospheres, the area classifications, what the markings are requirement for the manufacturers, and under the IECEX. And by the way, what you see here, these two nomenclatures, these are the European directives. This directive right here is the directive that applies specifically for area classification and the employers, the responsibility for the employer when they're doing area classification. This directive applies to the manufacturers of product. So just be aware of that. That's something that you just want to be aware of. So let's go again to this chart. We look at protection levels. And this is important to note right here. So let's see if I can do this again by putting a little drawing into it. So protection levels is right here, and our definition of protection levels. So when we have a product, if you will, that has two independent means of protection, allowing two independent faults, that's the type of product protection level that we would typically use in an environment in which it is an explosive atmosphere is present frequently or for long periods of times, which we would normally consider to be a zone 0 or a zone 20 environment. So for those of you familiar with intrinsic safety, because intrinsic safety generally is IA type equipment, that's where this A is, this EPL. That means an IA barrier has two independent means of protection, allowing two independent faults, and it is a protection concept that is approved for zone 0 type environment. Notice our 1G equipment categories and GA, again, it basically means the same under the IECEX as what it does under ATEX. They just have a different designation. Unfortunately, we've had a lot of harmonization between what goes on in the ATEX world and in the IECEX world, but they didn't use the exact same nomenclature, unfortunately. So let's move on. So area classification in the United States. So I realize that most of you are probably located overseas. You're not here in the United States. But there's a lot of influence from the National Electric Code that winds up in various parts of the world. So you might see this even though you're located in an area in which obviously it might be more IEC or EN standards, but sometimes in various parts of the world, they'll adopt in some reference to North American rules and regulations. So in the US, what we basically have, we have gas hazards located here. We consider those to be a class 1 hazard. If we have dust hazards, we consider those to be class 2 hazards. And then we classify fibers and flyings as a class 3 hazard. Instead of 3 zones like what we would normally find in the international community, we actually have 2 divisions. Now, the division concept was the legacy concept that has been around in the United States since literally the 1930s, 1940s, I believe, is when it was first introduced. The zone concept has been introduced in the United States and is referenced in Article 505 of the National Electric Code. So the definition of what we actually have for Zone 0 in the US is actually the same as what it is in the IEC 60079-10-1, where a Zone 0 hazard is a continuous hazard, a Zone 1 is an intermittent hazard, and a Zone 2 is an abnormal conditions exist. In general, and this is something just to be aware of, in the US, if we consider something suitable for Class 1 Div 2, that basically means in general, it's equivalent to Zone 2. That does not necessarily mean that we can put Zone 2 products into a Division 2 area, but the type of protection concepts are very, very similar. What you also notice here is that we see that Zone 1 and Zone 0 under the zone concept are actually very similar to the division concept. So the US, we basically said, in generalities, the combination of a Zone 0 and a Zone 1 environment would be considered to be a Class 1 Div 1 environment.
It does lead to some confusion, Bob, because you can have in the US or North America certification for both. So you can see a product is certified for class and division and one for zones.
That's correct. And there is a methodology. When the zone concept came out and was introduced in the United States, it was meant that if there was new construction going on in the United States, the client would have the choice of going either with the division concept legacy or the zone concept for new. And in certain markets in the United States, they adopted it very quickly. For example, up in Alaska, a lot of the facilities that were built in the 90s were around the zone concept because they had a lot of areas that were Division 1, and they said, well, look, we want to make it more Zone 1, and there was some flexibility that they gave them by using just Division 1 equipment. Today, within the US, you can, in fact, go into facilities and use zone-rated equipment into division hazardous atmospheres. However, that being said, the product still needs to be certified by a nationally recognized test lab in the United States. It doesn't mean that you can just use an IEC EX product or an ATEX product and start using that in a US installation.
So you're saying that if I have a UL certified zone rated product, I can, for zone 2, I can use it I'm planted to use in divisions in the US, or it needs to be recertified for division?
It doesn't necessarily have to be recertified. This gets a little bit out of what we're talking about, but I will give you this.
I had a question. There was a question on that, and I just want to.
Okay. Well, yeah. If you had, for example, what is allowed within the United States, if you had, say, for example, an area classification that was Class 1, Division 1, and you had a product that was Class 1, Zone 0 rated, right, by an RTL, you could use a Zone 0 product in a Division 1 area.
Okay.
If you had a Class 1, Zone 1 North American approved product, you could use that product in a Class 1 Div 2. You can't use a Zone 1 product in a Div 1 product. And there is some restrictions on Zone 2 products into Div 2 area classifications. But in general, there are some areas in which you can use a North American approved zone product in a division hazard. So that is
to be approved by an RTL. a nationally
It
recognized
still
testing.
has,
That's a
it still
difference.
has to be approved by an NRTL. It doesn't mean that you can just take an IECEX product or an ATEX product and automatically use that in a US installation. It does not mean that. So you would still have to go through that additional step. And that additional step, by the way, really what it deals with is within the US, the requirements are that products not only have to be certified for the hazardous location from a EX perspective, but they also have to be certified against fire and shock hazards, which are not necessarily part of the requirements, excuse me, within the 60079 standards in the IEC world or in the EN world.
It is very much so. In fact, we carry a lot of UL rated certified product, and they carry 2 certifications. So I forget, for the air classification, also for general electrical shocks and so on. And, and they're not typically the same certification we would do in the US, in Europe. So
that's right.
And definitely you need an NRTL certificate. It would be a lot easier if it was one certificate globally, but hey, it is not like that. Okay, I'll let you go on. Next slide, I guess.
No, that's a good question.
No, let me finish this one.
Good point. Yeah.
Oh, there is a poll here. Okay,
it's a poll question.
This guy is a little bit tough, but let me read it out to you. What would be the definition of a Zone 1 hazardous environment per 60079-10-1? Is it a place where a gas, vapor, hazardous atmosphere is present frequently or continuously, or where during normal operation, or occasionally during normal operation but infrequently, or occasionally during normal operation? Well, you made it really tough.
Yes, I did.
Okay, but anyhow, we're talking about Zone 1. So Zone 1 is not Zone 0 and not Zone 2, somewhere in between.
That's right.
So what is the definition of Zone 1, basically, we're trying to get here? Guys, as Bob said, we're not grading anybody. In fact, we can not even see your names when you vote, if you prefer not to. But it's interesting to see how what you know, and we can work on that. So it's of course a single choice, there's only one correct answer.
And I will give you a hint, and nobody has answered this, but it is not D, and D is actually, if we notice there, place where a dust hazardous atmosphere. Dust hazards are not Zone 1, they're Zone 21, 20, 22. Exactly. So that's a little bit of a trick.
There was a question why we left a few more minutes. They were asking about Group 1. What is a Group 1? I think you did mention
mining application.
Mining is Group 1. So, you have a lot of those.
So typically coal mines.
Coal mines, exactly.
Yeah.
In West Virginia, Poland.
Yeah, right. The reason why we treat mining a little bit different is mining is actually, the hazards are kind of a combination of both coke dust, if you will, which is extremely volatile, but it also releases methane. And so what you hear the term is fire damp. And fire damp is really a combination of coal dust and gases. So where typically most of our oil and gas facilities, it's usually one or the other. In the mining industry, it's generally a combination thereof. So it's a little bit more stringent. It's a little bit more difficult to achieve. But that's why we kind of segregate equipment and area classification. And so anything below ground is a Group 1. Anything above ground is Group 2.
Let me end the poll. Guys, give you plenty of time. Not all of you have answered, but no problem. Most of you have answered B, some A, and I believe 1 or 2 have answered C. So, Bob.
Yeah, no, you guys.
I might be, but I don't want to spoil it because I might be wrong.
Well, no, for the most part, you guys were right. You were paying attention. So again, the correct answer is B. So where a gas hazardous environment is present occasionally during normal operations. So that is our definition of what we would consider to be a Zone 1 area. If it's a continuous area, that is what we would consider to be a zone 0. If it's occasionally, but occurs infrequently, that's typically what is considered to be a zone 2 area. Right, right.
All right.
Okay, so we'll move along here. So now that we've kind of understand the zones and the area classification, now we need to start gas grouping or grouping of our gas, vapors, dust, and fibers. So within the United States, again, class 1 is typically our gas, vapor, or gas and vapors. Dust are class 2, fibers. I'll spend most of my time really going through the IEC world and talk about this. So again, group 1, we don't typically worry about that because that is associated with below ground applications. But we really subdivide into 3 different groups in the international community. We have what is called 2C, 2B, and 2A. So it's based upon a couple factors. Number 1, the minimum ignition energy, which is commonly referred to as the MIE. That's the amount of energy that it actually takes to ignite a flammable gas-air mixture. The explosive pressures, this applies to specifically flame-proof type products, which we need to contain an explosion. That is considered to be what is called the maximum experimental safe gap. And then the explosive range, which is called the lower explosive limit and the upper explosive limit. So we take all these gases and vapors and dust and we categorize them and we put these in particular groups based upon this information. The important thing to note and to remember here is that in the international world, there is more or less really 2 main gases that exist within a 2C environment. It is the most onerous, it is the most difficult, it's the most volatile gases. Acetylene and hydrogen fall into groups 2C in the international world. Most, 98% of the gases will fall either in 2B or 2A. So a vast majority of your applications that you'll find in industry are going to be basically 2B or 2A gases. So just remember that. That's an important thing to note. In the United States, it's also true. Although instead of having 2C, where it's both hydrogen and acetylene, in the United States, we break those out into 2 different groups. So group B is hydrogen, group A is acetylene. Okay. Now, there was a marking thing that was allowed up until fairly recently, and you might see this in certain products, where if a product actually had a mark of just a Roman numeral 2, it was inferred that that product would be suitable for all gas groups. And that was true. However, the standards have changed to where now every new product must be marked with the particular gas group. So historically, if a product was good for Roman numeral 2, which meant all different gas groups, it would now be marked with a Roman numeral 2C. And it's also important to note that if a product is suitable for 2C environments, it's also suitable for 2B and 2A environments, assuming other parameters are also allowed. Okay? Now we also get into what else is on the chart is ingress protection or international protection or IP codes. So the standard for this is 60529, and it's basically, it tests the ability of the equipment to withstand solids and liquids. So the first digit deals with solids, the second digit deals with liquids. So as an example, IP54 equipment, it means it's dust protected and it's protected against splashing water, okay? If we had something that was IP67, that means it's dust tight, no dust will be able to get into it, and we could actually take that product and immerse it in water, okay? Generally speaking, almost all EX equipment, with the exception of IS barriers themselves, must have at least an IP54 or greater, okay? So when we're looking at EX equipment, it should be IP54 or greater. IS barriers are typically IP20. And the reasoning for that is that we typically install barriers inside of a suitable enclosure that provides IP protection. We don't just take an intrinsically safe barrier and stick it on a piece of DIN rail exposed to the environment. One of the important things to note on this chart, and what's also important to remember, is IP66 is actually a more onerous test than IP67. So you'll actually see, in many cases, products will be marked both IP66 and 67 because it's actually more onerous to achieve or more difficult to achieve the IP66 test than it is IP67. In general, however, if a product has a IP66 or 67, that would mean that it would be suitable for all of the environments below that, meaning that if you require IP54, if you selected a product that was IP65 or 66 or 67, it would generally be acceptable for that environment. In the North American world, we have what are called NEMA ratings. There isn't a true, complete crossover from IP to NEMA. There are some generalities, but when we talk about, for example, a NEMA 4 box, that is generally going to be something like an IP65 type enclosure. A 4X box, which you might see in some specification, is basically the same type of enclosure, except it's a corrosion resistant box. So it might be made out of a stainless steel type material. The IP codes don't come into play with the 2-digit codes into any corrosion resistant or any specific details other than solids and waters. There are, however, when you go into the 60529, you will find letters that will affiliate with different specific conditions above and beyond what's just listed on the wall chart. Now, T codes, this is the one where it really confuses an awful lot of people. But EX equipment is going to have a T code, generally speaking. And it'll have a T code anywhere from T1 to T6. In the United States, we also have what are called intermediate T codes, but let's not worry about that for this particular exercise. So just remember this, if a product is rated T6, that means that that product on its relevant surface will never exceed 85 degrees C. And I use this example down here in the verbiage. If a product that carries a T4 rating, that states that the product under the maximum ambient will never exceed 135 degrees C. So if we look at T4, and I'm going to try to draw this, here's our T4. Here's our T4, right? And notice it says 135 degrees C. So that means if I have a product that's rated at T4, that product will have some sort of temperature, operating temperature of somewhere in between. It's going to be above there and below there, right? Now, if I have a gas or vapor, which all gases and vapors will also have T codes. And what you see over here are some very common T codes. If we look at this one here, and I realize it may be very difficult to read, but that's ethyl ether. It's 175 degrees C. Ethyl ether is a T4 gas. So what this means, in effect, is that if I have a T4 product, it will never get hotter than 135 degrees C, and I want to put it into an environment in which ethyl ether is present. It will not have an ignition, it'll have an ignition temperature of above 135 degrees C, then I can use that. So therefore, a T4 product can always be used in a T4 or hotter ignition temperature gas environment. That's what we're basically saying here. So if you notice, you see some of the very common gases and vapors that we'll see in industry. Those are some of the T codes associated with them. And all of that information is also published within IEC 60079-20-1, and that will give you all the information on the specific gases and vapors.
Yeah, because there's more than just electrical spark that can ignite your gas. So temperature is another way.
Temperature is very, very important.
Products, for example, that are certified for classified areas, you know, they have they go through a thermal analysis to verify under fault condition what are the hottest spot to verify what is the temperature class they can reach. Okay, well, we have a poll here, guys. I'll launch it. It's a lot easier than before. While you do that, while you answer this question, I will maybe pose a couple of live questions we received. But in any case, the poll is about what is, if you have a product or fault condition of 125 degrees, how should we mark it? From T6 to T2 or none of the above?
Right.
It's an easy question because we just gave you the answer, Bob. Bob, there was a question that said, of course, so if you were talking about EP67 not as more easier than 66, does that mean that I have an IP67 product I cannot use an IP, if I have a requirement for IP66? Can I use an IP67 enclosure?
No, that is exactly correct. You can't. Now, that's why, and I've experienced, I've had this myself, where I've had a client that requires IP66, and manufacturers will say, well, I have IP67. It's not, if you look at the actual 60529 standard and you read the details on it, it will not meet that requirement of the IP66. The jetting test is a much more onerous test. So this definitely does throw people for a loop, because you make the assumption that the higher the number, the better you are. But with regards to IP66 and IP67, it's actually just the opposite. And that's unfortunate because it has created a lot of problems out there. So what manufacturers have done, and I think I mentioned this before, but you will see double marking. They will market both IP66 / IP67. And that's the reasoning for that, because it's more difficult to get IP66. And people do assume that by using IP67, it's just going to be okay.
All right, let's end the poll. Then I may ask another question. Basically, guys, T4 was the correct answer, right, Bob?
Yes, yes.
And, you know, most of you have answered correctly.
Yep.
You know, it's...
And just one of the things when we do teach, for example, under the IECEX or Compex, we go through this in detail. So you're getting a 5-minute spiel on T codes. But this is one of the things that it does confuse an awful lot of people. So don't panic.
T5 would be better than T4 because it's safer. T3 will, you know, will be...
Yeah. Here's the thing to remember, to take away. If a product has a T6 rating, I can use it in any environment. If it's a T6 gas, then I must use a T6 product. That's the only product I can use. So from a product standpoint, the higher the number is better. From a gas standpoint, T6 is the most difficult gas to deal with. And there's only one gas.
I don't remember the table, but it's somewhere around 80 degrees, right? 80, 85 T6.
That's right. So 85 is T6. There's one gas out there, carbon disulfide, that has an ignition temperature of 90 degrees C. So that means we could not use a T5 piece of equipment in that environment. We would have to use a T6 piece of equipment.
You cannot bring boiling water in there.
It's very difficult to deal with.
All right, that's good. Well, there's a lot of live questions, guys. We will answer them a little bit later, so we can carry on the webinar. Yeah.
So, and again, I apologize because this is also information that we would do under a couple days. So we're flying through this, and I realize that. But remember this on your protection concepts. So we have all these protection concepts that are suitable for particular gases and dust. But here's the key thing to remember. There are 4 major types of protection out there. There's either energy limitation, which is considered to be really intrinsic safety, non-sparking, which is increased safety, containment, which is considered to be primarily known as flame-proof, and then separation. That's separating the gas from the source of ignition. That can be done by pressurization, okay? So the one thing to note here, and I'll highlight this, if you see these standards here, these standards are basically the protection concepts. So if I was to build a product doing it around intrinsic safety, I need to follow the 60079-11 standard. That's not necessarily a standard that you as a design engineer, unless you're building intrinsically safe equipment, would necessarily need to know. You just need to know that the manufacturer has built it to that standard and that they comply with that standard, or in this case, in the US world, it's built to those relevant standards. So that's the important thing to note. You don't necessarily need to know all these standards. You just need to know that those are the standards which defines the various protection concepts. So just a quick go through as far as energy limitation. This is where we limit the minimum ignition energy for the particular gas group environment, and we break them down into what is called EXIA, IB, or IC. This is intrinsic safety. That's an energy limitation concept. Increased safety is considered to be a non-sparking concept. So we eliminate the potential for a spark or arc to the design of the equipment. So you'll hear things with increased safety where we'll actually have creepage and clearance requirements, and that has to deal with the distance between terminals through air or on a surface. And we make sure that these are tightened down to where they can't loosen up just due to vibration. So there's no potential opportunity for a potential loose terminal to create an explosion. So that's the whole idea behind increased safety. Then another concept we have is flame proof, which is what many people are very familiar with, but we also throw in powder filled and enclosed break. So these concepts contain an explosion on the inside of, say, for example, a flame proof enclosure. We assume that the gas vapors will get on the inside, we'll cool it off with the flange, and it will not ignite the surrounding atmosphere. And then finally, the separation. So encapsulation, we'll encapsulate something in some resin. We could hermetically seal it. Pressurization, EXP, where we're, again, separating a particular flammable gas atmosphere from any of the electrical components that could create an arc or spark. There's also what is called oil immersion and restricted breathing. So these are all concepts, and if we think about it, all of the EX protection concepts fall within those four main concepts, if you will. So from an EX marking string standpoint, this is what we would actually mark a product in the US. We would say under the division concept, we'd say class, division, our groups, and our T code. Under the zone system, we would have class, zone, AEX. This is telling us US conformity, protection concept, Roman numeral 2C, T4. This portion of the marking in the US is basically the same as what we would find over here as the standard marking in the international community. So when we look at the actual international markings here, this is telling us it's ATEX, who's the notified body. The equipment group, again, this is an above ground application. Category, that's telling us it's a zone 0. It's telling us it's suitable for a gas environment. And then our EX string, and then our EPL, that's a requirement under the IEC EX. Then we also have a listing of our certificates issued by, in this case, BVS. So this is what we would require under the ATEX markings. This is the requirement this is what is required under IEC EX. Now this is also required under ATEX as well. So just to show a quick example, and I'm not going to spend too much time on this, but just to kind of hopefully, if you can read this top line right here, this is telling us it's for a surface industry, category 3. That means that this product can actually be installed in a zone 2 area by this Roman numeral or 3 and the EXNA. This 1 in brackets is actually telling us it's an associated apparatus that's providing protection downstream into a zone 0 environment. So EXNA is non-arcing. That means this barrier can be installed in a zone 2. Apologize for my scribbling, but it's providing protection into a zone 0 environment. Okay, that's the marking string that you would typically find on an intrinsically safe barrier. This is the marking string for dust. This is the marking string for mining applications. And then, of course, these are the parameters. On the North American side, it's rated to be installed in a Division 2 area or a Zone 2 area. And then it's also providing protection, and under the IEC world, it would be marked in the same fashion, or excuse me, in the NEC world, to where it can actually be installed or provide protection into a Zone 0, and it also can provide protection into a Zone 1. So there's a lot of information there that can be very, very confusing, but it's important to understand this marking when we're actually trying to select the product and do all this good stuff.
Oh, I asked you a question.
Slide.
Sorry, well, there was a T class, the temperature class, there were T4 or T5 in the next slide.
Yep.
Does that apply to the gas and the dust group, or is there a difference between?
Yeah, so in this case, the reason why we have a T code here and we don't have a T code here, right?
Right.
Well, this T code applies for the fact that it's being installed into a Zone 2 area.
Okay.
Because this does not allow it to be installed into a dust hazard, it's only providing protection downstream. There is no T code associated with it.
But
if that
otherwise
makes sense.
it would be. And
Otherwise, it would be. So if this had been marked with, say, for example, EXTD, then it would have to have a T code, meaning that it could be installed into, in this case, would be Zone 22 dust hazard. Okay.
And the T class would be the same.
It could be. Dust, the way you develop T codes for dust and gases are different. And I won't go into all that because we don't have time, but it is a different number. It's determined in a different fashion.
Okay.
So this is an example of a flame-proof product, and this may be familiar to some folks.
Yeah.
We'll just show you this. So this is our marking, basically the marking string here. This is telling us our ATEX information. It's above ground, category 2, which tells us it's suitable for Zone 1 and Zone 2 for both gas and dust hazards. The protection concepts. In this case, they put 2B plus H2. Basically, you could find this type of marking. Remember, I told you there was 2C, 2B, and 2A. Well, this product would be basically not suitable for acetylene environments, but it's good for all gas groups in 2B and 2A, as well as hydrogen, then a T code, and our gas group.
So that H plus H2 means there is suitable for second B classes plus hydrogen.
Plus hydrogen. That's correct. And here's that example of a dual IP rating, right? IP
so it's not it's not a 2C. It cannot be used in 2C.
That's right.
2C will include additional gases.
That's right. The only other additional gas that is in 2C is basically acetylene. So you could use this product in any environment, basically with the exception of acetylene is really what it's saying here. So there's our IP codes. There's our T ambient. This down here is our dust markings, okay? What we see right here, that's our dust markings, which we really haven't covered, but that's what you would see there. And then if you notice here, here's our IEC EX markings. And again, the IEC EX markings are the same as what you see right here, except we don't have all of this good stuff that really equates to ATEX. And again, the dust hazards under the IEC EX. So there's a copy of our certificate number. There's our certificate number there and any parameters. And then finally the ambience. So that hopefully should all make sense.
I believe we have a poll coming up, yes. And let me launch it here. Okay, guys, this is not an easy question.
This is not an easy question.
Yeah. But there is a right answer. What is the best answer? Describe the following EX marking. Well, you know, Roman numeral 2, parentheses 1, EXD, B, IA, second C, T6, GB, GA. It's a complex marking. We went through marking, you know, in what is it, 45 minutes now? Less, because I talked 10 minutes, so less than 40 minutes. So let's see if you can, there are some answers. Some are obviously wrong. But some can be.
I congratulate anybody who gets the right answer here, because this is not.
Definitely. I was not able at the beginning. I need to look. I only looked at this question now a couple of hours ago, but anyhow, it's not easy answer.
So if I might, I'm going to give some hints as we're going along here. Okay. So if you remember what protection method D or DB is, that's flame-proof. So we can pretty much cross this one out, correct? Because this
nobody answered that question already, so that is good.
Now we have a combination of flame-proof, and IA is a protection concept that's suitable intrinsic safety, right? So we have flame-proof and intrinsic safety. There's a couple other little hints here.
So that will exclude another answer, you know?
Yeah, so increased safety, no, we wouldn't have C.
So the answers are the A or B.
So it really comes down to A or B.
I can tell you that as of now, we have most answer are A, some B's. You guys still want to answer, or I will end the poll?
Go ahead and end it. We'll just go through this.
Also because we are running, you know, into 55 minutes already. Okay.
So most of you did get the correct answer.
And A was the correct answer.
Yep. So I'm going to close that. I'm going to close this before I do this. So what is the correct answer, and what are the key hints here? It is a flame-proof enclosure suitable for 2C. Okay, there's our 2C. Located in a Zone 1 area. The Zone 1 is given us by both the Category 2, as well as this GB right here, as well as DB, which is a Zone 1 concept. And the key thing was it contains associated apparatus. Associated apparatus is another term for intrinsically safe. And
that was the giveaway. IA was the giveaway.
That's right.
But 2, you know, was where I got hung up, because 2 was for Zone 1 and not Zone 0.
That's right. Flame-proof enclosure suitable for 2C gases located in a Zone 0. So that would mean that this would have to be marked TDA, which there is no flame-proof at this point suitable for DA. So B is definitely not the correct answer. So,
okay.
All right. I think, So
we do. You did very good. So, well, we have, as Bob mentioned earlier, or maybe did not, but we have also a poster on SIL, so on functional safety, which we will make available to you as well. And maybe one day we'll prepare a webinar on that. We have to get Tino involved with that. You know, we do functional safety training. We have divided our teams in 3 teams within GMI. Me and Bob is Team A, and then we got Mauro and Tino Team B, and then there's Andrea and Massimo Team C. And
I like the fact that we're Team A. Team
A. So, okay, let's go. Oh, what is this? Okay, summarize.
Just remember, it's important. Get your wall charts, read them. Understand here, the other thing too is wall charts change, standards change. Make sure that the wall chart you have is up to date. So that's, I see a lot of wall charts that people have that are quite old. It doesn't mean that they're bad. Just make sure that you try to keep up to date if you do use the wall charts. So,
almost like, okay, here's our contacts, details. Of course, we will share the slide with you guys. While Bob, we have prepared some question and answer that came through through the registration process. There are a few open answers, Bob, if you want to look at them as I prepare to launch the other presentation.
Yes, yes, please do. And
You can see it?
I can't see it yet, but hold on. Let me try to answer some questions. One question, are there many differences in the way classification is determined between the 10-1 IP15 and API 504, or do we typically end up with the same outcome? Yeah, that's a great question, Gary. No, is the answer. We do teach an area classification course under the IEC EX scheme, the COPC scheme. And there is, you can, Gary, I tell you what, instead of going through this in detail, drop me a note and I'll be happy to share with you kind of some of the differences of what you would actually find. The most, I would tell you this much, if you want to really get it down pat, IP15 is the most exhaustive methodology of doing area classification. And it's very scientific and it's very good. The 10-1 and 505 are more kind of like we put bubbles around things. The 10-1 is also being republished, and there's going to be a new version, and I think there's going to be a lot of similarities between 10-1 and IP15.
Okay, I have a question there.
Yeah, are gas groups assigned to EXE equipment, will they always be 2C? That's another good question. Yes, I have, as far as I know, I have never seen a piece of EXE equipment that is gas group dependent. It's always going to be 2C. So a lot of EXE equipment, you'll always, previous stuff, you would find just with the Roman numeral 2, and now they'll be marked with a 2C. So no, that's a very good question. Can we consider a higher band of level for energy limitation for 2B, 2C area? What is the criteria? I'm not sure if I understand that question is, yeah.
Let me share the presentation here. Okay. But in any case, Bob, you see it right? You guys see it? All right, so let's go. The first question we received online was, what EX concept would be recommended to use specifically for lighting or high power applications, such as a switchgear? Mm-hmm. This is the answer we prepare. Watch what you all prepare. And
yeah, and increased safety with supplemental protection concept make the most sense. So increased safety can be very cost effective, obviously. The limitation, we typically have to combine increased safety because we can't have arcing and sparking devices inside of an increased safety enclosure. So we combine protection concepts. So for example, that floodlight right there might combine a combination of an increased safety housing with encapsulated drivers and LEDs. So that in and of itself would be probably a more cost-effective solution than maybe flame-proof. When we talk about starters and all of those types of things, typically up to 1,000 volts, either EXD or EXP is certainly a great, either one of those options. EXO is really used for extremely high voltage applications, but you can still find in some cases EXD equipment and in some cases EXE. Obviously, if it's low power, I'm biased, but I use EXI.
Yeah. Okay, the next question was about differences between ATEX and ICEX. Well,
yeah,
basically the same.
Yeah. So ATEX is requirement within the EU, but you will find some countries will adopt it or accept it, but it is mandated within the European Union. IECEX is approved in other countries. It's based upon the 60079 standards. Technically, the product has no different safety characteristics. They're built to the same standard, if you will, the EN version or the IEC standard. The big difference under ATEX is you can actually, the manufacturer can do a self-declaration for Zone 2. Under IECEX, it's not allowed. The EX marking strings are identical, and we saw that with that one label, with the exception of the ATEX requirements requiring the little EX, the CE mark, category, and all that good stuff. But generally speaking, a product that carries ATEX in many cases will also carry IEC-EX. If it doesn't mean that it probably couldn't. It just means that most likely the manufacturer has chosen not to get that certification.
To spend a little less money.
And spend a little less money. Yeah, if they're not exporting out of Europe and they are only selling into the European market, then there's no reason to get IEC-EX.
Yeah. Okay, so the next question is about EXE. There's several types of EXE equipment that can be housed in an enclosure placed in zone 2. What kind of explosion protection of the enclosure needs to be? That's a good question. I always get this confused myself. If I have a EX, zone 2 rated product, such as GMI barriers, what type of enclosure does it require to go in zone 2?
Right. So EXE, and it's now being changed to EXEB. The old increased safety is now being divided. There's EXEB, and there was the old EXNA, which is now EXEC. So it's a lesser form of increased safety. So for EXE equipment, there couldn't be any arcing or sparking, right? The same thing would hold true for EXNA or EC. They basically both had to meet a minimum of IP54. The impact resistant requirement for EXE is a little bit higher than what you would find for EXEC. So here's the thing. If I have arcing and sparking components, say general purpose components, I basically am not allowed to put those inside of either an EXEB or EXEC enclosure, because we can only put certified equipment on the inside of EXE enclosures. So for example, the picture on the bottom right, we have barriers and power supplies that are certified in and of themselves EX, and we're putting those into a EX housing, excuse me, that's providing the mechanical protection, the environmental protection. So, Paulo, to your question, as far as barriers are concerned, if you were to install those barriers into a hazardous location, the barriers themselves are certified for Zone 2, and they can be installed into Zone 2, but what it'll say in the certificate for GMI, and this is true for other manufacturers, a barrier shall be installed in an enclosure that meets the requirements of 60079-15, which was the non-arcing standard, if you will, which states that it must meet an impact resistant, must meet a minimum IP rating, and all that good stuff. So
it is correct. There's a note in the certificate that you can, you need to install it in such enclosure.
That's right. And here's the key thing to remember on that. If you have general purpose equipment, you cannot put it into increased safety equipment and be certified. You would have to go with either flame proof or purging and pressurizing, or do something else.
Okay, we're close. We went over 1 hour. I see, guys. Let me see if you guys are still there. Yes, most of you are. Let's take a few more minutes. A couple of more questions we received. Does humidity and corrosive environment affect the EX equipment? I believe so.
Yeah.
Here's some examples.
Yeah. So remember, IP ratings deal with solid objects and water, but don't necessarily address the corrosion resistance of a particular piece of equipment. So as an example, those 3 pictures, what you see below, are pieces of EX equipment that, yes, from an EX perspective, they are fine, but maybe because of a material characteristic or the corrosive environment, they very well may not have been suitable based upon the fact that either the materials were incorrect or possibly how it was installed. So what you're seeing on the right-hand side is actually an aluminum enclosure with a gland that's going into it and that dissimilar metals. So again, it's a certified enclosure, a certified gland, but the moment that we put it in there and we throw salt water into it or a certain environment, we could have all kinds of problems with dissimilar metals. The picture in the middle, that's actually a Zone 1 motor that was actually only in service for about 3 years. So you can see that it's not in very good shape. So yes, we want to take into consideration the materials of which the product are actually designed around. So using stainless steel, a 316 stainless steel, corrosion resistant materials are certainly all things that we need to take into consideration.
In fact, if I remember correctly from our other webinars, we need to do this inspection every about 3 years, right? Recommended.
That's right. Yeah, that's the maximum interval between inspections is every 3 years.
There is an interesting question, Bob. You know, we said basically that EXE rated product needs to go into an EXE enclosure to go install in zone 2. Does that mean also the other way around, that all products that need to go in an EXE enclosure need to be EX certified?
Yes.
I'm thinking about like terminal blocks, say a terminal block.
Yes. So for example, a Weidmuller terminal block, can I just, inside of an EXE enclosure, can I just populate it with any terminal block? Well, basically, no. You have to use the terminal block that the manufacturer has gotten their product certified to. So what a manufacturer typically will do, first off, they will say, you can use this brand, this type, this number, but they will all be EXE certified terminal blocks. You can't just put general purpose terminal blocks inside of an EXE enclosure and be done with it. It must be a certified terminal block, and it must match up to what the manufacturer has got their enclosure certified to using.
We have one more question in your life. Let's see if you can answer that. Why instrument JB, so junction box, are mostly select EXE and not EX non-sparking? I don't understand. EXN, EXE instead of EXN, yes.
Well, no, that I understand. So why instrument junction boxes are mostly selected EXE and not EX non-sparking? Well, it's a good question, and I think the thing is, if you remember the difference between an EXE enclosure and an EXN enclosure, basically they both had to meet the minimum IP ratings of IP54. But the real difference is that the impact resistance test that an EXE enclosure has to go through. So therefore, EXE boxes have to undergo a more rigorous impact resistant test. And generally speaking, that's usually a much more robust enclosure that you would want to use in an industrial application. And if you really think about it, the cost differential between, say, a junction box that's rated EXE versus EXN is not that big a difference. There is a cost difference, but generally it's not very much. So people generally will just go and use an EXE box because it typically is a little bit beefier. And also, sometimes people will buy a box and they don't know if it's going into a zone 1 or a zone 2 area. So if I get an EXE box, I know I can use it in both applications.
All right. So question was, how do I get GMI wall chart? Of course, as we said earlier, we will drop one to all of you guys, or you can send us an email. And, you know, we have, of course, online version. We also have printout that you can put on your wall. Many times we get this question. We are interested in a different webinars. We have many live webinars. You can look them up in our schedule online in the GMI website. There is also all the webinars we did, including that of today, being recorded, and they will be on our YouTube channel. Now, before we let you guys go, take a few more seconds to answer this poll. Let me see if I can launch it here. Launch poll. How did we do? And as you answer that, I will go to my closing slide so you can see our contact details here. So you can write us email and then stop share. Well, that I don't know how to do anymore. Here we go. There we go. Great. Well, I say 90% of you answered excellent. Thank you. And a good one. Thank you again. Most especially thanks, Bob. I haven't seen a question to place to Bob that he was not able to answer in any of the webinars.
Oh,
this will happen. You know, you guys have to pose some tough questions because he is super prepared.
Well, the good thing is, I mean, I must admit, almost every question that I get is usually something that I've been asked before. So that's a good thing. And as Paulo mentioned, we do hope during this whole COVID thing, we do plan on offering some more formalized training, both in person and webinar based, in the EX world. So keep abreast. We'll let you guys know if you're interested, because we are going to be doing that worldwide and doing the certification under the IEC EX COPC scheme.
Yeah,
So
very soon. Great. Again, Bob, can't thank you enough. We'll see you next time. Enjoy the rest of the day. And thank you guys for being with us. Bye.
bye.
Ciao.
Ciao.